Time may not exist in the way we imagine. Let's take a concrete example: atomic clocks. Atomic clocks are the most accurate ever created by humanity. They are so precise that even over a period of 13 billion years, roughly the age of the universe, they would only lose 1 second. In other words, they tick at such a regular rate that you could almost use them to measure absolute time. But what happens when you move one of these clocks? That's where it gets interesting. Let's imagine we have two perfectly synchronized atomic clocks. As long as they stay side by side, they always show the same time. But if we move one of them even just one floor up, we notice a tiny difference between them when the moved clock returns. The two clocks, even though they work the same way, no longer show the same time. And that's something that should blow our minds. Because if time existed in a universal and absolute way, the two clocks, no matter how perfect they are, should always stay synchronized. And yet, that's not the case. So that raises a question. What is the second clock really measuring? This experiment shows us that, in reality, time is not universal. And if we can't rely on atomic clocks to give us the time, then the very idea of absolute time no longer makes sense. And that has much deeper implications. There doesn't seem to be a common time for everything that exists. And instead of that, each object, each individual has its own duration. Each clock, each being, each particle could have its own proper time. But is it logical to think that there are an infinite number of different times, each attached to a clock or an individual? This idea quickly becomes unmanageable. And it's precisely for this reason that physicists come to the conclusion that time doesn't exist in a universal way. One of the most striking examples of this absence of universal time is the Langevin twins thought experiment. Conceived in the 1920s, imagine two perfectly identical twins. At the beginning of this experiment, they are the same age and in the same place. But then, one of the twins boards a spaceship and leaves for a journey at a speed close to that of light. When the traveling twin returns to Earth, he is amazed to find that even though little time has passed for him, his brother is much older. That means the two twins did not experience the same amount of time. This paradox raises an important question. If time really existed, how is it possible that two individuals of the same age could end up with two different ages? It also shows that our intuitive perception of time, the one we use every day to organize our lives, is incompatible with physical reality. What we perceive as time is actually a subjective and local notion, unique to each person.